This meeting is being recorded.
Who is that recording this session?
No, we don't know.
Your mic is open.
Yeah, I just on the mic, but I didn't record it.
No worries. Okay, share your screen.
This is the issue I was getting. I was trying to run the Terraform apply auto upload.
Okay, so it says that resource that you have created is not available in that resource. That public IP address is not available in that resource. It's
Okay.
clearly telling you that you are trying to add a public IP. You have the
Yes.
code with you right away. The code with you.
Yeah.
Scroll down. Scroll down.
Yeah.
So can you search with the name called public IP alpha?
Yeah, this is on the public IP alpha, this one.
Scroll down. Scroll down. Slowly. I want to see that reference for the public IP. Scroll down. Scroll down. Yeah. Continue. Public IP. Scroll down. Go upwards. There is no reference for the public IP.
Yeah. In network interface, here network interface, you have mentioned that one public IP. I just changed this only. My resource group name only I have changed. Other than that, I didn't change anything of the code which you have
Where did
sent.
you get this code from?
You have sent the zip file, right? Terraform package zip file.
Okay, fine. For the purpose
Yeah.
of practice, do go ahead
Yeah.
and comment. For the purpose of practice, just comment this public IP address just for the
Okay. This one.
right? So what you have
Yeah.
to do, if you go to terraform.io, there will be a public IP address reference. So you have to get something like resource in double quotes, public IP address. The name of the public IP is example.id. So let me go ahead and give you an idea about it. Then you can, with
Okay.
you blocking, commenting whatever that you comment as part of, I'm sharing the screen. So whatever that you go ahead and what you have to do, first you have to block it, so that what will happen, it will start working for you without the public IP. If you want to have a public IP, terraform.io, I think you are using the previous Terraform. Try to use the latest code that I gave. So I think you are referring the previous code. I could see that you are referring the previous code. So registry into AWS cloud. Under that, get to see, sorry, we are on the Azure. Azure underscore virtual machine, because you are provisioning the virtual machine. Azure virtual machine.
Linux.
What I'm looking at.
We have to give the Linux, right? Azure Linux, I think. Linux virtual machine.
Yes. Yes, this one. We go ahead and look for this VM. There is a public IP address to be given. Public IP, public IP. I think I have given this public IP address. Maybe you're referring to the previous code. Just check if I have given the latest code, because in the latest code, I remember I gave the public IP. So also check and
No,
also
Kumar, I
check.
have taken the new one only on the last class, Terraform last class. You have right in that class. From that, I have taken that only.
No
I
worries.
have revised the class also again.
No worries. So this is the reference for the public IP. So this is how you should include the public IP, Azure RM underscore public IP. Here example will become alpha, the name of the public IP, which resource group, what is that? This is what is a reference. Use it as a reference in your code. Add this one into your code. It will get there. Instead of that, alpha replace with example, or if you are continuing with alpha, put it as alpha. So it is the resource. It is clearly telling you there is no public IP address reference resource created in your main.tf. Go ahead and use it. You add it. It will get. This is the reference. This is the reference for the public. It means there is. It is expecting a resource called public IP. In your account, there is no public IP reference. Now you have added the reference for the public IP. It will
Okay.
recognize.
I just have to give the name as example. In place of example, I have to give the alpha, right? Other than that,
Right.
I no need to change anything.
Right. No worries. But make sure in your resource group, is it example? The resource group name is example. You should continue with example. Location,
Okay.
what location you give.
Yeah. And the name of that one means acceptance test public TP1 is that right? Do I
Anything.
need to change it?
It's a name. Any name
Okay.
is anything. Something that you can check. You can put xyz.com also.
Oh,
Name is up to you.
yeah.
Okay. So are
Can
we
you
good?
please
But
share that zip file also? Terraform zip file. I just recheck it once.
I don't have it, because I told you already from the day itself, whenever I
Yeah.
upload it, I make sure that it is given on the day. I don't have it. If someone have it, please share it. I will share with you. If anyone has that Terraform code, anyone, if you're having the previous Terraform code, you can share with me. I will share with him. Okay, fine. Let's continue, participants. Okay, so participants, one interesting topic, which is about the database, which I gave to the last part of our discussion. Like I wanted to go ahead and keep it to the last part of the discussion. So the database that I wanted to go ahead and spend time is NoSQL database from Azure. Yeah, participants, can I continue?
Yeah, hi Kumar. Sorry to disturb you. I have joined today itself. May I know what session is going on? And hello, is this?
So participants, we will discuss about the database, which is the NoSQL database offering from Azure Cloud. As part of the Azure Cloud NoSQL database offering, we have this database called CosmosDB. The term CosmosDB is the service that you will find under Azure CosmosDB, like, sorry, under NoSQL category, you will find CosmosDB. So if you see a database is always expected to behave certain important categories. We all know that databases are expected to go ahead and behave or give something called asset properties. Most of you, I'm sure, are aware of asset properties from a database, asset from databases or asset and databases. If you look at asset database. So what is the meaning for the word called ACID? The acronym for ACID is atomicity, consistency, isolation, and durability. These are the 3 or 4 major keywords that will define how a database should behave. A stands for atomic. That means if there is a transaction happening via a database or into the database, it should be complete. It cannot be half commit or half complete. It should be fully completed. So that will go ahead and make sure that the database and the data that is stored as part of your database is consistent. So atomicity is guaranteeing you that the data is making sure that is complete, the transaction is complete. Because of this, we can expect the data to be consistent. That is where the next C comes in, consistent. The data which is before transaction and after the transaction are consistent. And I means isolation. Isolation means in case if there is a database, like one transaction happening, there is another transaction happening. I don't want those 2 transactions to, what do you call it as, affect each other. The transaction should not affect each other. I stands atomic, consistent, isolated, and durable. Durable means assuming if there is some kind of failure in terms of the node where the data is getting stored, my data should be still available for me to read. It should not impact the entire database. So these features actually make the database to be very, very powerful. Or basically our relational databases are RDBMS, we call it as relational database management systems, follow this property. For a long time, RDBS has been very, very interesting topic. A lot of organization used. But because of the social media, because of the resources, a lot of companies have shifted their operations into non-relational databases. Non-relational databases or NoSQL databases actually behave the other way. Instead of following the asset properties, they follow the base properties. What does the base stands for? Basically available, soft state, and eventual consistency. They follow this property. Base. Basically available, soft state, and eventual consistency. Now, you don't need to go ahead and understand them in detail, but if you have an idea about it, that's good. So what the asset properties couldn't address, base have addressed it. Base means your data is made available. You can read your data. In a state, you can easily read it. It is made available. It is something that you can read. But if your consistency, when it comes to consistency, you have to make sure that there is some time that gets involved. There's some kind of time that gets involved. Or the time is something where you feel, or if you go and look at the consistency and availability, they'll guarantee you that, okay, you can read your data, but for consistency, let that it get updated. So this process of databases, base properties have been picking up by a lot of organizations. And that's where the advent of NoSQL databases came into the picture. NoSQL databases. And one such popular NoSQL database in Azure we have is CosmosDB. So CosmosDB is a database service that is available in Azure, where you go ahead and start storing your data the way it is received. So currently, CosmosDB supports databases in the form of document database, in the form of key value database. These are all NoSQL category databases. So let's jump in to provision database, which is the Cosmos DB account you have to provision. And participants, this is also very, very, very costly. This is huge cost involved when you go ahead and start using it. Very careful, be very careful with the cost. I'll show you what is the cost it will happen. So here it will ask you which API will better suit. So are you looking for a NoSQL database, right? So are you looking forward for a MongoDB kind of service where you store in the form of documents, or Cassandra service, or you're looking for a Gremlin service or a PostgreSQL database service? So these are databases that are very well known in the NoSQL category. So here Azure is guaranteeing that we can go ahead and give you the NoSQL category database service offered under this Cosmos DB. So to make it easier for everyone to understand and relate, let me just go ahead and use a Cosmos DB for NoSQL. Let me just go ahead and use, instead of this, we'll go ahead and create a Cosmos DB. And into that, let me just go ahead and use pay-as-you-go model, and whatever the resource group you have, account name. So let me just go ahead and give an account name, Cloud Cosmos DB. Location, keep the location wherever it is. Now there is an option that will ask you in terms of the capacity, because it's a database, so you consume the services. In the process of consuming the services, Azure has to charge you. Azure have to charge you back. So when it comes to charging, you, Azure has to keep in mind two things. How much storage that you are taking from them is something that they will take into consideration. Plus, how many number of read-write units that you read-write means there is a database. How fast will you read the data, and how fast you retrieve the data from the database is taken into consideration. So those options are taken into the scenario, and those options are taken into consideration. And this is where you will go ahead and say, okay, possibilities that my database that I have possibly have to have, maybe possibly running with this kind of reads and runs per unit. So that's what he says, based upon the number of reads unit that you get to have per second, that is measured in per second, read units per second. You will go ahead and give the information saying that I might use these many number of read units per second. Now, I'm not sure about read units. I don't know how much will happen. So let it be serverless. Serverless means how much you use. After your usage, you will get the bill. Here, you can go ahead and say, no, I will make sure that I will go ahead and remain in 100 read units per second, maybe less than that. I will remain in that criteria and start using 25 gigabytes of storage of storing my data. I will store it. If something which you are not clear, then we can shift to serverless concept. Serverless means whichever is actuals, on actuals you will get the bill. So at this moment, let's remain on this mode, because I will avail the benefits of free tier. I'll get 100,000 read units per second and 25 gigabytes of storage into the free tier. And expected cost is about $64 a month, which is discounted for me. So you can enable free tier upon one subscription. Estimated cost is $64 a month, discount per account. Okay, so let's keep this option, and this is a limit that will apply. And let's do a review and create it. So this is expected to take a couple of minutes for this database. So it's a valid account that I'm creating. So let me go ahead and create the database. Okay. Now my resource is readily available. So in this scenario, now you guys can see an account is created, which is the CosmosDB account, where idea is to store the data in its format. So whatever the format that I want to go ahead and store the data into, I want to store it like a document database or a key value database. So how it is possible for Azure to store this data? So let's do one thing. Let's go ahead and understand by creating a container. So what is meant by container? Container means so a service you are taking. Inside that service, you need to have a space where you can go ahead and store your data. So you can start storing your data in. So we'll go ahead and first create a container. Right. So what is the definition of a container? You take services from Azure. I take services from Azure. You take services for Cosmos DB. I take the services of Cosmos DB. Because it's a service. So Azure has to go ahead and say, okay, since you are trying to store your service on Azure Cosmos DB, create a container. A container, you can treat it as like a server. Just for example, visualize that you're trying to store your data that is going to get stored into Cosmos DB. So how you will allow the data to be written? So create a container, like a kind of a server. It's not server, but it visualize it's like an interface where you try to go ahead and do all your computation and store your data into Cosmos DB. So it's a way for you to write your data. So let me just go ahead and put my container ID. Let's say I want to go ahead and store about very random data. I will store. I would like to store about my users who are working on movies. They are having some movies. They want to go ahead and store. I want to store about the database movies. So you want to share this container across the databases? Yes, I can. How do you want to go ahead and scale this database throughout? You can put it auto scale. And container ID. How do I identify one container? Because we'll start storing containers. So this is a movies database. Inside, let's say movies container. Inside that, I will go ahead and identify them by the container. So let's go ahead and identify each one with the movie name. Movies database, and now each movie. And what is a partition ID? How do you go ahead and identify? So I'll go ahead and put it as MID, movie identification number, some kind of identification for a movie. So in that way, I will go ahead and create my Azure Cosmos DB account, and I'll start storing the data. Now see, how will I go ahead and allow my Cosmos DB to write the data? Now I did create a container. Into that container, I am trying to store the movie. Now, instead of databases, which are currently, if you look at SQL databases involve first database creation. After the database creation, you will get tables. So that logic of tables you can understand and visualize right now. The movies table and rows and columns that you do is now the data that you store in the form of rows and columns is something that you can relate with an item. You want to store an item. Right now, the item is nothing but a document storage. Create or work with existing documents. So let's go ahead and create a new item. So participants, what I will do is to make it more easier for you to relate. Let me just go ahead and put some MID here. So that becomes the identification. ID is given. Okay. So identification, let's go ahead and put some more reference. Let's say this identification I'll give is M01. For example, 100 identity. That is a document ID. Or even before that, let me go ahead and write here. Then I'll copy paste the documents. So I'll write two documents. So one document about one movie ID is 100. And the name of that movie, I'll keep it as it's a number, right? So let's keep it practical number and movie name. Let's say the movie name recently released, for example, Triple R, and in that there are actors. I would like to go ahead and store information about the actors. In that, male actor is done by Charan and Mr. NTR. So these were the two actors that played a role here, major role. So let's close this first. Okay. Double quotes not required. Yes. And as part of it, once it is done, this is about male actors. And we can also pass about co-actress, like female actress. It's only one I just mentioned. Okay. So any challenges, which is this one. So there's only one actress. I'll just keep it as an array, not an array, just one entry. One more closure is required. This is one. Okay. Let's keep this as male actress at this moment. And for this male actress, this one. And I will make it as. See, purposefully, I'm doing all this, people. There is a reason why I'm doing all this. Female actress. Because you should be asking me this question, that on what basis you are storing all this information. Definitely, that's a question to be answered. That's where NoSQL databases are very, very powerful. So we are passing an array and year of release, 2021. Okay. Now, participants, if you look at this document is just storing the data, whatever it is received. So let me just go ahead and give this document and pass this document as a reference. Now, question to all of you participants, where did I go ahead and mention that I'm going to go ahead and store this data? That I will store the name of the movie, that I will store actors information, I will store female actress information, year. Did I mention anywhere in the database creation while I was creating any database? Did I create any such schema? Any such schema did I create? Think for a minute, guys. Anyone? Anywhere did I design? Anywhere did I design? Participants, nowhere I have designed it that I should be going ahead and storing the data, because I did not mention anywhere that this is the piece of data that I'm going to store. Nowhere I mentioned it. If I did not mention anything, the context, we call it a schema. This context, we call it a schema. This is the schema that I want. Now, we did not define anything before. That's what we call it as schemaless. We are not defining the database to be storing the data. It's completely schemaless. Are we good, everyone? Hello, participants. Are we good now? You're able to relate? Participants are able to relate. Now it's purely schemaless database design that we have done. Because of this schemaless database design that we have done, let me go ahead and first save this. It's a document. ID must be a string. Okay. ID must be a string. It's allowing me to receive the data where it is and it's storing. Now there's a document that I've been creating. The first document. Now it is received. Now let me show you another example. Another document I'll show you. This time I will change the document name. Let's more complex. Okay. Now in this, there are a lot of characters that who have played. So one is Ranbir. The other one is played by couple of. Nag was playing the role. Amitabh was playing the role. See, now I'm increasing the list, and Production company, the company that has produced this is Dharma company, Dharma Productions. And you know, we are, which genre does it belong to? It does belong to genre about science fiction. It's a movie that come under drama. This is some information about drama piece. And what more can we add? There has lot been VFX. Just a number I will give. It's 80% of 50% of it is done using VFX number. Just to mention something. And Alia and year of release 2022. And producer information. Mr. Karan. Okay, now see, from the first ID to the second ID, now we'll change the ID 101, for example. So the first ID to second ID, see how changes have happened. Since I'm aware that there is no schema for me to design, I'll add another item to store my data. ID must be string, double quotes. Okay. Now, participants see, from the first document to the second document, there's been a lot of change. In the first document, it was just an ID with name, male, female, year of the release. And here, same will continue here, but we have changed name, actress, company, now extra pieces of data that is coming in company. We have year of release, we have producer information, we have VFX information, we have genre information. See how documents are able to go ahead and we are able to store the document. So one document versus another document. Instead of saying document, we call it as item. We store the form of item. Why item? Item can be document, can be a key value pair, can be anything. So that's where CosmosDB can help you to store the data that is received. The way it is received, we store it without defining the schema upfront, especially in the form of documents we have seen now. So what is the advantage of storing this? The advantage of storing is, one, clearly you will understand, participants, as a database developer, did I go ahead and design any schema upfront? The clear answer is no. That means we will save a lot of time in designing the schema upfront. But when it comes to SQL databases, you are required to create. Otherwise, you will not store your data. In a database like SQL, first you have to make sure table creation is addressed. First, you have to create table. Then you have to go ahead and start storing your data into those tables. And also make sure if there are tables, you have to have relation between those tables. How these two tables will relate your data. So that means first thing I have to make sure if I'm creating similar products like products company. So there are two things that I have to take care. One, I have to go ahead and create product table where it will store the product information, and purchase done by the users. That means users information. How a user is associated with the table. So user 1 from user table has purchased product number 10, and the relation is something that I have to go ahead and remember. Now coming to SQL databases, this is the story. Now let's go to NoSQL databases. NoSQL database, no information. I know that the same logic, if I can go ahead and put this document, or I can go ahead and put this one in this scenario, something like this. Continuation to that example topic. So I can go ahead and create a document. The document is nothing but now 200, for example. It's the name of the product, user ID. Guys, just keep this movies discussion a little aside for a minute. So user ID is some USR 101, that is a user ID. What are these products that he has purchased? Products that he has purchased. Products that he has purchased are, mobile he has purchased, and he has purchased a charger along with it. That's it. First information is gathered. Next, in continuation to that, let's assume that there is another user who is now 201. His user is USR 201. His user ID is USR 201. He has purchased the products. The total, he has purchased a laptop. Okay, and he made a total bill, which is some 20,000 bucks, 3,000. And is he a what is his service satisfaction? What is his service, or what is his rating for the products that he has done? He has rated about 4.5. And is he a member for a particular membership, for example? Membership, is he a membership? Yes, some membership. The answer is no, he's not a member. So why did I go ahead and show you what I'm trying to show is, here in the design of user tables and products, when it comes to SQL category, I have to design everything upfront. Here, whatever the application starts writing into the form of document, we are going ahead and gathering. So we are gathering whatever the products information we are able to get. Next time he made a purchase, we got the bill, but the bill information was not mentioned in the first document. In the second document it is mentioned. Or the other way is, he was not giving, this user did not give any rating, but this user gave the rating for the products he purchased. So rating information is stored now. He was not at all interested to share his information regarding his membership, which was not mandatory for him. But this guy shared it. He said, no, I'm not a member. So it captured membership equal to no. So the idea is, now we are having a document way of storing the data wherever it is received. Now, participants, if you want to go ahead and now query, because querying is most important. So storing of data is now addressed. Let's go ahead and query now. So what I have to query now? I have to query the, what I want to query is, I want to go ahead and query what are those users that are open the query. Where is that case? Go to the resource, databases. Where is that database? That is my database, data explorer, movies category, movies database, items that I've stored. I go ahead and run a query. The query is like this. New SQL query. Select star from the current container. What movie names did I give? Or let's first run a simple query that you can all relate with. Select star from container. This is good, the query. So it will list all the values, first and second value, all the documents it is listed. I want to go ahead and container where I'll put a clause where container.id is equal to 100. I'm very specific on this. ID, I should match particular ID. Yeah, it is matching the first document. Where c.name, name of the movie should be equal to what name I gave, I'll just run through. So still I'm able to run my SQL queries. My point is that I'm able to run my queries. See, now it is picking up Brahmastra. Everyone are able to relate now? Hello? I'm able to store the data in the form of documents and able to run my SQL queries. That's why it is called NoSQL. NoSQL means not only SQL. It's running your SQL queries. It's not that it will not run your queries. We can run your SQL queries. Why it is different is we are not having the burden of SQL databases where the SQL database expects us to go ahead and create schema upfront, standard procedures involving asset compliances. All these burdens are taken away. We are just receiving the data the way that we can receive from the application without designing the schema. Schema-less design is given. We store the data. So the data is now available for me to read. Data is basically made available for me to read in a state. If something gets updated, if this data is getting updated, if I have to go ahead and update it, this updation for me to take, it will be update. The data will only be available if that event for update is happening. Otherwise, it's very difficult for me to keep the data updated across all the nodes. So in that way, base properties play a very vital role for your NoSQL databases. So participants, have you now understood what is a relational database involving Azure SQL databases we have previously seen, and to NoSQL databases like CosmosDB we have seen. Are we good, everyone? Hello, participants, are we good? And make sure that you go ahead and bring down your account. Otherwise, heavy billing will happen into your account. So go ahead and delete your account. So it is asking as a feedback. Or let's skip this feedback and delete your account. The account name is done.